So, as a procurement-related video series, I suppose we should talk about competition and companies. Now, there's not very many companies in the world of quantum just yet. Some of the bigger IT companies are getting involved, such as IBM and Google and Microsoft. Indeed, Andy obviously works for IBM, so he's not allowed to favour them in any of this segment.
Maybe
But
biased.
I think it's important as a procurement professional to start thinking about, okay, what's your ecosystem look like and which suppliers you're going to engage with. And Andy, I suppose, without getting into too much detail of the individual companies, what would be the sort of things procurement people would need to consider in terms of pedigree, looking for companies to engage with?
So there's quite a lot of startups specialising in very specific quantum application areas. Let's see over there, look.
Another one.
Yeah, cool.
Oh, there he is. Oh, yeah. Can you get him? Oh, he's dived.
Solid one.
All right, go back up.
Yeah, he's doing breaststroke.
Is he going out for a bask? Going to come over. You got any fish? I know he's gone under.
Yeah, it's gone. Oh,
How cool.
yeah, cool.
Sorry. So,
Okay. So quite a lot of startups. So if you've got a very specialised application area, it might be worth looking at one of those. But in general, if you're looking for your journey to quantum, then you want to find a company that's got the ability to offer services in advising you on which algorithms in your enterprise estate are more likely to be amenable to quantum. And those should be backed by somebody who's got an actual quantum computer to use. Most people today, I have to admit, are using IBM's quantum computer because we've got the first commercially available quantum system. And a lot of the vendors are, like for example, some of the big four, are talking about quantum computers, talking about quantum applications, and then saying, and when you want to use one, here's the keys to IBM's systems. So you can actually do real quantum computing with companies that haven't actually got a quantum computer. The other thing to think about is when you want to start, you think you might benefit from a quantum computer. So people are actually using the noisy intermediate scale quantum systems now to solve, as I've mentioned, sort of small versions of problems that they face, knowing that they'll be able to solve bigger problems once the quantum computers are bigger. If you're thinking that you need perfect logical qubits to solve some very specific problems, then you might want to wait a little bit further down the line, maybe sort of 2029 sort of time frame, which isn't very long now.
no.
But as I reiterate, you need to be learning now, so you're not caught by surprise by all this stuff in 2029 when everyone's using it, and you'll lose competitive advantage if you're behind your competitors.
So, just have you got an idea roughly how many quantum computers are there in the world today?
Well, if you include it in research organisations, there's probably hundreds.
Okay.
We've got about 20 odd online available via the cloud. We don't know how many are in China.
Right.
The Chinese government invested a huge amount of money about 5 years ago in quantum research, long before and much more than the UK government is, unfortunately.
Mm-hmm.
So they may be further ahead. It's hard. We can only really tell from the academic papers they publish, and those probably by their nature are
Censored or
a smaller version of what they're really doing. So we don't know, and that's one of the big risks for the quantum safe stuff, is that they might be close to cracking RSA and we just don't know yet.
Yeah, and I suppose at the moment it's the preserve of the big boys, so the IBMs, the Googles, the Microsofts, etc. But to your point, it's accessible because of the cloud consumption-based metrics, and over time, do you think more and more people will own quantum computers, or do you think it will stay in the cloud mode because it's so expensive and complicated?
Well, at the moment, there's only really two reasons for buying a quantum computer. One is because you want one.
Because they look pretty.
Exactly, yeah. Something big and shiny to have in reception. That's what Germany did. Angela Merkel wanted Germany to be the first nation state to own their own quantum computer, so they bought one. It's now the Fraunhofer Institute in Einigen. Very pretty it is too. And the other is if you're doing something so secret, you don't want anyone to know anywhere what you're doing, and we know what kind of organisations those are. Couldn't possibly comment whether they've bought them or not. But other than that, For the foreseeable future, you're probably going to want to access them via the cloud. But eventually, we'll have these quantum-centric supercomputers, which is a whole load of classical compute, a whole load of GPUs for the AI, and a whole load of quantum processors for the quantum part, solving massive problems.
Okay.
And we're going to see those probably as bureau compute in the first instance, but potentially appearing in data centers in the longer term.
And so you've got the hardware layer, which is all, as we've just discussed, and then you've got the services layer, which is, I mean, there's probably not that, outside of, the big boys, like I mentioned previously, there's not that many people who are involved in this. I mean, the startups community, is it fairly healthy?
Well, startup community is very, very healthy, yeah. I mean, we're seeing, it's the thing to be in at the moment. And we're seeing lots of different, mainly startups specializing in specific, either hardware or in specific application areas.
Interesting, okay. So as a procurement professional, you probably need to start thinking about just doing some basic research. What sort of companies are there out there in terms of the hardware layer, what the consumption models are around cloud for these things, because I can imagine it's not cheap at the moment, but it will come down over time.
Yeah, it's not hugely expensive, but it will definitely come down over time, yes.
And then, finding the right quality supplier for the advice and the services is going to be key. Are there sort of known accreditations or sort of exams that people do?
Yeah, so Qiskit is the Python library that's the open source.
Can you spell that?
Qiskit.
It was a yes, no answer. Yeah, well done, you passed.
See what you did. Yes, I can spell it, and that's what it was. So it's the open source quantum programming language that IBM developed originally, but then open sourced. It's a Python library. Most of the quantum hardware manufacturers now use Qiskit as their programming language of choice, so we don't get a massive proliferation of quantum programming languages, because this stuff's hard enough as it is without having multiple languages. So you can do the Qiskit Developer badge and the Qiskit Advocate badge, which is sort of understanding more about the application domains. And those we're starting to see people with that on their CV.
Interesting.
And people are starting to hire quantum programmers, so it's definitely the thing to have. We're expecting to see a generation of quantum software engineers coming out of comp sci degrees pretty much from this year and next year onwards.
And you're heavily involved with the University of Portsmouth, you mentioned earlier. I mean, degree courses, is it in comp sci, or is there a specialist?
Mostly in physics degrees at the moment.
Yeah.
It does include the programming, but there's an assumption that you need to understand the quantum physics in order to do the quantum programming, which seems a bit odd to me, because you don't need to understand how a transistor works to use an Excel spreadsheet. So why would you need to understand how qubit works? But that's where it is at the moment. We're starting to see quantum programming showing up in comp sci degrees. And I'm sure that'll only grow, because it'll just be one of the programming languages that you learn when you learn to be a programmer.
So in short, as a procurement professional preparing for the next 5 years, you probably want to start thinking about business applications that might benefit from this, and that's quite specialist. And you as a procurement professional might not be able to answer that, but maybe engage with friendly people like your good self, Andy, and other people in IBM or other big vendors that do quantum, to start to think about how this could affect you strategically. Obviously, procurement people are putting in place 5 to 10 year contracts in some cases still, so they need to consider whether any of the applications they're looking to buy, or any of the services arrangements they're putting in place, have the potential to move to quantum, because that will affect the way they're currently licensed. And over time, start thinking about building partnerships with academia and startups where appropriate, to see if you can start learning a bit more about it, and potentially offering up use cases for people to accelerate the benefit.
Exactly, yeah. And there's one other key thing for procurement organisations, that they must insist that any software system they buy from now on is quantum safe, because NCSC and governments are starting to say that by 2035, anybody doing business with government will need to be using quantum safe technologies. So this stuff's definitely coming, so put that in your procurement. So
quantum safe, just to summarize, because I think you mentioned it previously, was safe from being cracked by a quantum cyber thing. Go on. Explain it in layman's terms for me.
So it's using the new post-quantum cryptography algorithms, which are not amenable to being cracked by a quantum computer that's probably going to show up in the next 10-ish years' time, which will thus invalidate all your encrypted secrets.
Perfect, okay, all right. So quantum safe is important. And it's interesting, on a project I was working on, which I can't talk about, it's one of the big areas, was over a 5-year period, making sure we're buying equipment that has got that quantum safe technology, because once you've installed it, it's a bit difficult to uninstall it sometimes and thinking that far ahead is really sensible.
Yeah, and we're starting to see with IoT as well, because I mean, IoT devices will typically have, Internet of Things devices will typically have a 10-year life cycle. And so the CRA, which I can't remember what it stands for, but it's the legislation's already in place and it kicks in 2027, will insist that IoT devices are secure, which in today's world means quantum safe secure.
Yeah, interesting. Okay, brilliant. Well, look, thanks, Andy. Now we're safely out of the harbour, I'm going to go a bit quicker and get us back on stand, and we'll try and film final videos as we're going into the harbour.
Cool.
Thanks very much.